Hello and welcome back to yet another tutorial. So we are back to my favorite ever, Vellum, and we're going to be talking about this scene over here. Now this one is kind of basic, but there are a lot of really cool little tips and tricks in when you're doing Vellum inflation that I'm hoping will help you in some of your future projects. So let's jump in and let's take a look. I'm in Houdini 19.5.640, 640, and I just have a geo container which I've made yellow. You can hit C and you can make it yellow and you can dive inside. I'm going to start with a sphere and I will make it polygon and I'll make it 4. So I just have a sphere and I know I'm going to make this a little bit smaller, something like that. And then on this side, I'm going to use an add. And the goal here is that I want to copy this onto a point. So I'm going to just use a single point. That's what this is creating. If we do a copy to points, there we go. I have it exactly where it was, but now it's copied to this point. So if I move this point, this will move. So that's useful to me because what I can do now is use a point jitter. Because essentially what I want to set up here is the emission. And I don't want the emission to always be the same. I want it to change. And so what I can do here is I can hit $FF. And now when I move this around, you can see that this point that this is being copied to is moving around. And so my emission kind of sphere will constantly move around, which is what I'm going for. All right, so the other thing, I'm just going to make this one. So this is essentially just making it the same size as it originally was. Somebody recently asked me how I deal with sizes in Houdini, and sometimes I'm very conscious and I think very hard about the size and the scale of the scene. And sometimes I kind of just go with an R&D session and I just start using things in their default state. And my scene gets really big, but it works. So I kind of just leave it. And this project was one of those. I was playing around with this and everything got really big. When you see the final product, you'll see that I'm in a very big space. It's like 25 by 25 and that's meters. So these things are like these huge giant balls. But I get this really cool behavior. And so I'm just going to kind of go with it for this tutorial. But obviously you could shrink these a lot smaller and you would get slightly different results because the Vellum solver and all the wind and forces very much depend on the size of your objects. All right, so we have our emitter. Let's add some UVs so that we don't forget. I will set this to be polar and that looks good. So now I have this moving around and we will create a camera soon. What I do know is I want this to be much higher up, somewhere like that. So now they're moving around over there and they're going to fall into kind of a bucket or a tank. And then we can also do an attribute randomize. Well, we'll leave the attribute randomize for right now. So then what we can do is we can create a Vellum balloon. And I pretty much left everything at default. I turned this way down so they had a lot more room to grow. And I made this a little bit stiffer. And so the reason that I changed this one was I wanted when they expanded and got bigger, I wanted the polygons to be able to grow without trying to constrain to their original shape. And then you get this kind of really weird bouncing and twisting. And I wanted this to be higher so that there wasn't too much wrinkling. Otherwise, when they shoot out and got bigger, there was like this really weird kind of blowing up effect. And the Vellum pressure. And pressure, we can just kind of maybe bump it up because we want this to be the hero, and we'll add a group here and say P stretch. So what we're going to do now is just add nulls. And this is out geo. And I will make these black. And then I'm hitting the Z key and I'm getting these and I get this. And then I can add a Vellum solver. Now, you can do this in a .NET, which is maybe a little bit cleaner, but you can also do it here. And the way to source here is if you add something into the third input, then it'll work. You don't have to add something into these two, even though it says required, but you do need something in this one to do a sourcing, which is kind of weird, but that's just how it is. So if I plug this in here and I grab those, and I can go out geo. Now you can also go here and you can go and find your geo. And if you do it like this, it does it the same. But if you see, then it does it, whatever this is called, the absolute path or relative path. The reason that I don't like to use this kind of writing is that if I copy this setup into another project and this path is different, it doesn't work. And when you have multiple of these, it's hard to kind of go in and find out where they are. But if you do this relative path kind of setup, it will just work all the time. So the emission type, I want to do each frame. And if we hit play, you'll see that I'm getting a ball each frame. Now this obviously doesn't work because they kind of all stick together, which is kind of cool in its own way. It kind of looks like liquid. So what we're going to do is use this activation, and we're going to use a modulo function. So if I do modulo 10 and then equals 1, what this is saying is every 10 frames basically emit. So you'll see 1, and then on frame 10 or 11, it's going to emit, and then on frame 21, another one comes in, and obviously now they're intersecting, but that's okay, we'll fix that. And now we get 1 every 10 frames. So that's working. The other thing is we want to set up a stop so that it doesn't kind of render forever. And I'm actually going to just change my frame range to, or my frames per second to 25. And I'm going to stop this at, let's say, frame 400. So what I can use is I can use an and, if I can find it. Where are you? And there, and. And I'm going to say $F is smaller than 400. So essentially what this is saying is do this and meet the condition that if $FF, or if your frame $F is smaller than 400, keep going. But as soon as we hit more than 400, and we'll set this to 600 and turn this off. So you'll see that it's on, off, on, off, on, off. But after we reach 400, now it's just off permanently. So that's cool. So now it won't just emit forever. All right, so let's set up some collisions so that this has something to glide into. The first thing we'll set up is a box. And what I want to do with this box is it needs to be quite a lot taller and quite a lot bigger. Something like that looks good. And then we need it to sit on the floor. So what we can do is we can use a match size and just set that to min. So now it's on the floor. I mean, it doesn't have to sit on the floor, but we'll set it to sit on the floor because why not? So we have that, and let's just check what this is. Okay, so we can move this way up, and we can do it. They transform center. And somebody asked where I got this from. This is from the AE libs. It's a free toolkit in Houdini. It's quite cool. So I can set that there. Then I have my box. And we may need to adjust this, but for right now, we'll kind of just leave it like this, I think. Okay, so we can pop that in. And the other thing that I added in here was a grid. And I made the grid have a lot more segments. And then I actually used the labs sine wave. Now, this is a very kind of subtle effect at the bottom, but if you have a look over here, you will see that it gives us kind of like cool secondary motion that as the spheres hit it, they kind of bounce around in different directions and then they move. So it's not just a static floor. And I felt like this was kind of cool. So just something like that and just moving around. So if we merge these two, we have this box and that. And what we need to do is just move this box down a little bit so that this becomes our base collision and not this flat grid. All right, so that's looking pretty cool. What we can do is just check this out. We need to make sure that this is not getting clipped at the top now. So we can pull this down a little bit. Let's just make sure that if we have a look at this and this, that they never go above, and it doesn't. But what we can do is we can maybe make this jitter a little bit bigger so that it goes further side to side. So we can make this one smaller, but then make this one quite a lot bigger, maybe 5. So now it's going, if we go to the front view, it's going nearly to the ends. We don't want to, obviously it's go to the end, but now it's clipping the top. So we can either just pull this down, and that seems to have fixed it. And we can also, for good measure, just turn this higher just a little bit to make sure that it never clips the top, because obviously if it clips the top when it emits, it'll just stick there and it creates issues, which I did have, so I know. And now if we go into this view, and let me just, firstly, I'm going to increase this to 3 for now. It will eventually need to be higher. And let me just give it a lot more RAM and hit play. All right, so we have these spheres that are moving in. I can get this going. Okay, so what I'm going to do here is just make this a vertical camera and a nice long focal length. What I ended up doing with this camera actually is changing this from perspective to orthographic. That just helps me with the perspective lines, so that when these kind of push against the sides, it looks like it's pushing against the sides of my camera too. And I think I need to set these to 0. Okay, maybe not. Set these to 0. Okay, there we go. And now we can slowly move this back. Maybe not so slowly. Okay, so the other thing is that we want to see more of the bottom and less of where they're emitting, so we can just move this whole thing up. All right, so what I'm going to do is just create a file cache. I'm going to need it anyway, and it just makes it easier when I'm iterating things. So let's just call this Vellum inflate tut, and I will save this to disk. All right, so I did about 200 frames, and that's enough to see what I need to do with my camera. So you can see we're not seeing the emission, but we are seeing the base, and I don't really want to see the base. I want to just see the effects of the base. So I will pull this down a little bit more, and we still don't see the top. We just kind of see these things falling down, and we see something at the bottom, which is cool. So for the camera, and that is working well. Now, in general, this is still kind of boring because there's just a bunch of these falling down. So let's talk about how we can inflate them. If you've watched any of my Vellum tutorials, you know I have this Vellum get attributes. Now, what this is just a geometry wrangle, and I've set this up so that I can save it onto my shelf. And the way that I do that is I just make this and then I drag it onto the shelf here. And this is just a little shelf that I made of my tools. And I created this. So what this is, we can create one from scratch, is a geometry wrangle. And I named this Vellum get attributes. And this is kind of my go-to whenever I want to deal with anything inside solvers that uses a point attribute outside. So we first need to set up the inputs. So I'm going to use myself dot data, and then this one's going to be the subpath. Now, the way that I got this was Vellum constraint properties. If you have a look at the inputs here, I'm basically copying this, and I'll copy this, put this in here, and this one maybe should be that one. Okay, so I'm just copying what side effects has done. They seem to know what they're doing. And then here I need to fetch something, right? But in my case, I'm not actually fetching an attribute. We're going to create the attribute inside the solver, and I'll explain that in a minute. So we just need these two, the data binding, because we're going to affect the rest length, we want to work on constraint geometry. Now, if you're new to Houdini, if you have a look at our geometry stream, there's nothing that affects the growth or the size of these. But if you have a look at the constraints, you see here we have rest length, origin, stiffness, and these are the effects. These are the attributes that we want to affect. And this is on the constraint geometry. So that's why we changed this to constraint geometry, and constraint geometry is primitive. As you saw here, it's not a point attribute, but a primitive attribute. And so we can set this up to run over primitives, and we want to run over our piece stretch group. Now, if you forget, Our P stretch group is the one that we set up here for our pressure constraint. And so when we affect stuff in this wrangle, we'll only be affecting our pressure constraint. Okay, now we can't see anything because of our box, so we'll just hit W over the viewport, and then it toggles wireframe. And now we can write some stuff. All right, so let's create an integer PT. And what we want to do now is we're going to look up a point attribute, but we're working in primitives. And so we need to use a prim point function. And what this is going to let us do is to look up point attributes on our in our primitive wrangle. Essentially, that's kind of like the base of it. So we can just set this up like this. And this is going to look up the first kind of result of on our primitive of our point number. Now we can look up an age attribute. Now we haven't created an age attribute yet. We will in a second. And the reason I'm setting it to 1 is that I'm going to create it inside my DOP. And so I wanted to use the DOP data. And so then I want to do something with this age attribute. And essentially what I want to do is I want to say if age is greater than a number. So let's just say if this is greater than age value, and we will set this. If it's greater than that, then you can do something. And what do we want it to do? We want to do the trusty rest length is at rest length orig multiplied by a value. And in this case, we're going to create an attribute called inflate. So let's do that. Float inflate is going to be so it's going to just be an amount. So we want to say that if age is smaller than, let's say 5, then or bigger than 5, then you can inflate. And how much do we want this to inflate? At the moment, let's just say something like 15 for good measure. So just to quickly recap, what we're doing here is we're creating this here to get the point attribute onto our primitives. Then we're creating an inflate amount. And then we're saying that if age is greater than a certain value, which in this case we're saying 5. So once the spheres have been alive for 5 age, and in this case it's going to be 5, I think, seconds, then increase their rest length. Now, the reason that we do rest length is if we adjust it and we just times it by this, each one is different and they will go crazy. So what we need to do is we need to take the original rest length that Vellum sets up and then multiply that to create a new rest length. So this is the way that we do that. So now obviously nothing's going to work because we don't have an age attribute. And so we can use a pop wrangle. And this one is a very simple one. We're just going to say if at age times equals at time inc. Not times, but plus times inc. Okay. And this time inc is a value or an attribute that Houdini has built in, and it's kind of the time step currently being used for simulation or playback. That's like the official definition. And this is super useful when you're doing velocity and stuff and you're building those on your own. You can multiply it by time inc so that it's scaled correctly based on your substeps on your solver. But in this case, what we're wanting to do is once something's emitted, you'll see now, it creates a time inc kind of value, and then we can very easily use that as a kind of a counter. So let's just hit play and we can take a look at some of this. Okay, so that didn't work. They all did inflate, but I wasn't getting the age attribute right. And what I did here is I made a spell error. So that should have fixed it. All right, so now what you can see is you can see some of them inflating. So if you have a look at this age attribute, you can see that when they're emitted, okay, so there's nothing, there's just 1, and it has an age attribute. Let's go forward one. It has an age attribute of 0.04, and it slowly counts up. Now, as soon as another one is emitted, you can see that they have an age attribute when they're emitted. Let's see, we did 10, so on frame 11. Now we have another one, and it starts with an age attribute of 0.02 and 0.4, and then the next one on frame 21, again, we get a 0.02 attribute, and these ones have grown up now to 0.8. So these ones are growing higher, and then this one is starting from the bottom. So we have kind of a counter of each one that's being emitted. So we are using that to say, once this passes 5, now you can see these first ones are going to pass 5, it's going to inflate. And we get this cool wobbly inflation, and they slowly bounce up. So that is working as we would hope, but we're not done yet. So the next thing we want to do is I want to add some randomness to the sizes of these emissions. So I'm going to use an attribute randomize. I don't want to use color, I want to use p-scale. This is a single float, so I'm going to change dimensions to 1, and I can say this is going to be 1, and I want this to be a value of 2, and in the seed I can just hit $F. Now each frame I'm going to get a slightly different size, so that just adds a little bit of randomness to this, and because pressure is dependent on the scale of your objects, this radically changes that as well. And before we do a final sim, I do need to increase this frequency up to 8 so that we get slightly nicer kind of folds as it expands. So we will do that, but to keep things going, I'm going to keep it at 4 for right now. And the other thing I want to play with is this one I'm going to set as pressure, but I want to duplicate this one, and I'm going to set this to be the constraints other than pressure, which is basically stretch and bend. And I can write in here stretch and bend, but I like to just keep it like that. It's a bit easier. And this one's going to be, and I know that this needs to be a lot smaller, something like 1.15. And let's cache this and take a look. All right, so if we jump into our camera and we turn off the UVs and wireframe, you can see we get these kind of cool spheres that grow in, and then slowly you see one by one, no matter where they are, they inflate. And this is quite cool. Now we're getting a lot of intersections, and this is happening. So when they emit, you'll see, especially in the beginning here, they emit and then they don't emit far away enough from each other. So we can just kind of come back to our settings here, and maybe we need to have quite a bit more on our height, so we can just double check that our box is not being intersected again, and it still seems pretty good. And just need to make sure that it's going high enough away that it doesn't affect that. So I think that's a bit better. Something else that we can do is just give them a little bit more time, or a little bit less time, depending on what you want. But because they're moving up and down, it doesn't always help, because they fall into the next one. So we'll kind of keep that for right now. The next thing I want to do is I want to add in some randomness to the amount that they inflate. So right now they're all inflating by the same values. So by 5 in the pressure, and by 1.5 in the, not 5, 15 in the pressure, and 1.5 in the bend and stretch. And I want this to be random. And so the way that I can do this is I need something to kind of tie this randomness to. So I can add an attribute wrangle in here, and we're going to just create an index. And the index, we can just base this on the frame number. So we're going to write an attribute called index. We're going to create an integer value, and we're going to just say at frame. Now, the reason I have to say int here is that frame is a float, and I want this to be an integer. So if we have a look here, we can see that this one is frame 175, but this sphere, if it's emitted, is going to have a value of 125, and this one's going to have a value of 69. So that's cool. Now I have a random value per emission frame, or per piece that's being emitted. So if I go into here, what I need to do now is call this value in here, and I can do this by here. I'm going to bring in my index. Int is an index, and I'm going to use, again, pretty much the same as before, index and pt, because I'm pulling in a point attribute. And now instead of floats just being a single value, I can now fit 0, 1 this. So I'm going to take a 0 to 1 value, and I know that if I use a random function, I get 0 to 1. So I'm going to randomize index. So every time index comes, it's going to be a 0 to 1 value. And now I can set this up to be a min or a max. All right. So I can set these up and I don't need this one. So I can delete spare parameter. Yep. So now I can set up a min and a max. So let's go a little bit less and a little bit more. So we have this huge value is going to get really big, and then some of them are going to be a little bit smaller. And we can do the same thing now in this one. So let's copy this and paste this in over here. We don't need this, so we can delete spare parameters. We can create our new parameters. And this one we want to be quite small, so 1.5 and maybe 3. All right, so now we're getting close to the final step, but there is still something else. But let's render this, or let's simulate this and see what it looks like, and then we can do the final step. All right, so what we have so far is this. And let me just toggle real-time play so that it doesn't look ridiculously crazy. And we have all of these spheres falling in, and there's still some that are catching each other, which is not ideal. So we can play around with different seeds and values and see if we can find ones that are not as crazily intersecting. But in general, I think this is working quite well, and you can see these are popping and they look quite cool. Now, I didn't simulate all the way to 600, but it's working. So something you'll notice is that when they inflate, they are quite crazy and there's a lot of motion to them. And so I wanted to add some dampening. So if we jump in here and we add a pop drag, and let's say we set this to 3, what you'll notice is, so if we have a look at our cache, you can see that these are really far down. And if you have a look at our simulation with the pop drag, it drags everything. So now our gravity is way reduced and these all intersect each other. And this is obviously not ideal. So I need to limit this to only be affected once they inflate, which we're inflating by this age attribute, which I have. And so I can use this in this vex expression. So it's always good to have these attributes on hand. And so what I can do here is I can say if at age is greater than 5, the same as we've done in all our other ones, we want to do some stuff. And the first thing we want to do is we want to say air resist is 3, or it can be any value, but we're going to use 3. That's what we had here. And if you have a look here, this tells you the value. It says the air resist. So I know that air resist is 3. And then else, and now we can just set up kind of like the default, and we know that we want air resist to be 0. So it's going to be 0, and then when they inflate, it's going to be 3. So let's just play a little bit more with this value here. All right, so I'm going to just times it by a random number and hope for the best. Sometimes that's the best way to figure that out. I mean, there's ways that we can try and de-intersect and whatever, but for now, I'm not going to do that. The other thing I'm going to do now is just push this up to 8 segments so we get slightly nicer results. And the other thing I need to change here is the substeps. Now, because I want them to have better collision with the colliders, and when they collide, they don't kind of poke through, I'm going to increase this value to 6, but this is a multiplier of the constraint iteration. So I can turn this down. So I'm going to increase substeps, but turn down constraint iterations. And this kind of balances each other out. So let's do another test here. And this way I'm going to do the full 600 frames, and I'll see you in a few minutes to take a look at what we get. All right, so I finished running that simulation and I'm pretty happy with these results. I really love Vellum. I find it super fun and interesting to watch. I love how some of these fall in front and then expand and pop up. And there are some that are still intersecting, which may be worth kind of running a couple extra iterations and seeing if we can find some that aren't right in the front that intersect. It's generally okay if they're intersecting and you don't see them behind, but when they run in front of the camera, it's not as fun. And we can also move this around and find a different angle. But in general, I think this is working super well. You can see how as they inflate, they don't go crazy because the velocity dampening is really just smoothing them out, or the pop drag, I should say. and it fills up the space really nicely in a very satisfying way. So I hope you enjoyed that. I hope you got some cool nuggets out of this one. And I will see you in part 2 where we will render this and make it look pretty. See you then.